All right. So this is the fly catching problem. This is the easier way to solve it, where we set up the numbers in lists in a spreadsheet, and we do a regression analysis. And we get this curve, right? Y is equal to x squared minus 38x plus 392. And that's your model. You're supposed to set up, what is the question again? Create a second degree polynomial model that gives the number of caught flies on day X of July. And that's what we've done. So that's the model we want. So we can write that down as our solution here. The model is y is equal to x squared minus 38x plus 392. I'm not going to bother with the correct notation here now, but that's x squared, okay? It's just easier for now. So we have our model. And the next question is, use the model in question A as the starting point. What day was the fewest flies caught? What day was the fewest flies caught? And some of you misunderstood the question here, I think. Thinking that, okay, which of these 3 days were the one that fewest flies were caught? And obviously that's the middle one, the 16th of July, 40 flies. But that's not really what they're asking here. Which day during this time period was the one where fewest flies were caught? So to do that, we have to find the minimum point for this graph, because this is a model that allows us to predict data outside of the table that we're given, right? So we're supposed to use the model, and to do that, we have to copy this graph into the graphics field. So it's usually a button like this. It's also in a newer version, right? Where you can sort of copy this to the graphics field. So click this button, kopier til grafikkfeltet. And now it pops up over here, right? So this is the same graph, but now it's turned into a function. We can manipulate the axis to make it look better, right? Like this. We can now use these buttons up here to find, for example, extremalpunkt, extremum. So that would be the maximum point or the minimum point. This curve has a minimum point. And clicking on the curve, it gives me the minimum point 1931. It means 19 is the x value, so that's the number of days. On the 19th of July, 31 flies were caught. The y-axis gives you the number of flies. So, B. 30 flies were caught on July 19th. Question C. What is the instantaneous rate of change? What is the instantaneous growth rate or rate of change on July 26th? Give a practical interpretation of the answer. And instantaneous rate of change, that was the last thing we looked at before the test. And if we're going to find that in GeoGebra, instantaneous rate of change is the It's the gradient of the tangent in that single point, instantaneous rate of change. So at a single moment in time. So to find the y value for the 26th, we now have a function, right? It's called g of x here. I could write in g and then 26, and that'll give me the number of flies on that day. And that's 80. So I now know the point that I want to enter here. I could write that in as a point, like this. The x value is 26 and the y value is 20. So this is how you enter points into GeoGebra. You just write them in normal parentheses like this. This will be easier to see on the video. And I click enter, and I have a point here. It's called B. Now, the next step is to draw a tangent in that point. I go to this menu, go down to tangent, and I click first on the point and then on the curve. And here I can read off an equation. It says y is equal to 14x minus 284. What I'm interested in here is the gradient of the tangent. And the gradient is 14. So the instantaneous rate of change on the 26th of July is 14. Give a practical interpretation of the answer. Okay, it means that on this day, the number of flies increase with 14 flies per day. So it's the growth rate, if you like, or the rate of change.